Alright, let's talk for a second about finding complex roots. When we have something like this and we have an x in the middle, it gives us a little bit more of a challenge when we're finding roots that might be complex. We know we don't have whole number roots because if we tried to factor this, which if you recall when you factored in the past, you look for factors of the number on the end that add to equal the number in the middle. There are no factors of 5 that add to equal 2. Our only choices are 1 and 5. So we know that we're going to have numbers that are not whole numbers. They may be complex numbers, but when you cannot factor, what we do is we go back to using the quadratic formula. Now the quadratic formula, what it does for us is it tells us the solution. If we were to set this equal to 0, it tells us the solutions to any quadratic. Okay, quadratic is when you have the x squared and the x, or really just an x squared. You don't even have to have this center part. Okay, so what we're going to do now is use this to find our roots. Now what do the a, b, and c stand for? A is the number in front of x squared. B is the number in front of x, or the coefficient of x, and c is our constant term. Okay, so in this case a would be 1, b is 2, and c is 5. We go ahead and put those into the quadratic formula. So it says we do negative of b was 2, plus or minus the square root of b squared. So again, b was 2, so we have 2 squared, minus 4 times a, which was 1, times c, which was 5. And then we have the whole thing is divided by 2 times a. Okay, what do we have from here? Well, we have a negative 2 plus or minus the square root of 2 squared is 4. And here negative 4 times 1 is negative 4 times 5 is negative 20. All divided by 2 times 1, which is 2. We continue simplifying, okay, because now we have our root 4 minus 20 is negative 16. And notice from here, I know that my roots are going to be complex numbers because we have the square root of a negative number, which means our answer will involve an I. What is the square root of negative 16? Well, the square root of 16 is 4. The negative gives us an I, so the square root of negative 16 is 4I. And that's all divided by 2. Now notice in this case we can divide 2 into each part. Okay, you can split it if that makes more sense. So we have negative 2 over 2 plus or minus 4 over 2i. 2 divided by 2 is 1, so we have negative 1 plus or minus 2i. Now what does this plus or minus mean? That means we have two answers here. They were just saving space. We have negative 1 plus 2i, and we have negative 1 minus 2i. So our two roots are negative 1 plus 2i and negative 1 minus 2i. And what we know about factors is that the factors will be x minus any of your roots. So we have x minus negative 1 plus 2i. Now that looks a little complex. And we have x minus negative 1 minus 2i. Those are our two factors. It looks a little crazy, but when we get into complex number line, it does have a bit more to it because we have a real and an imaginary part to our number. Now when we get to this slide, how do we know what type of factors we might have? That might be something that would be helpful, just to look at a problem and know, are my factors going to be real numbers? Are my factors going to be complex or imaginary? Am I going to have just one of them? And so this is another way that the quadratic formula comes in handy. Because a little trick we have is, remember that last example we were working on, we knew immediately, as soon as this number under the square root was a negative 16, we immediately knew that we had complex or imaginary factors, because taking the square root of a negative number gives us that imaginary part. If this had been a positive number, we would know it was a real number answer because we can take the square root of a positive number and get a real result. The other option is not positive or negative, but 0. If you were to have 0 here, that would give you just one answer and it would be a real number. The reason there's just one is because we would add 0, giving us the same as subtracting 0. Doesn't make a difference. So we call this part of the quadratic formula, we call it the discriminant. Okay, the part under the square root. And we call it that because it allows us to discriminate and decide what type of roots we will have. Again, if you have the square root of a negative number, okay, you know that you will have complex factors. If you have the square root of a positive number, you know you will have real factors. And if you should happen to have a square root of 0, that will also be real, but you will only have one of them. Whereas if these other two, you will have two, the positive and the negative. Alright, so let's use that. Let's look at these problems, which none of them factor. So we would have to find the roots using the quadratic formula. Let's say we just wanted to be prepared and know what type of roots we're going to have. What type of factors are we going to have? So let's try that out. Again, we're using the quadratic formula. So our a, again, is the number in front of x squared. Our b is the number in front of x. And our c is the constant on the end. So we have 1, 2, and 4. And we're just going to calculate the part under the square root. Okay, so that tells us to do b squared. So 2 squared minus 4ac. So 4 times a is 1 times c is 4. 2 squared is 4 minus 4 times 1 is 4 times 4 gives me 16. And 4 minus 16 is a negative 12. So what type of factors would we have? Well, if this part of the quadratic formula is negative, we're taking the square root of a negative number, so we know that we have complex factors. Okay, let's try another one. Here's one here. Again, our a, our b, and our c. We're just doing the discriminant, so we have b squared, so negative 2 squared minus 4 times my a is 1 times c, which is negative 4 this time. Negative 2 squared, or negative 2 times negative 2, is a positive 4. Negative 4 times 1 is negative 4, times a negative 4 is a positive 16. And 4 plus 16 is 20. So for this one, we know the number underneath the square root is positive, which means that we will have real factors. And finally, let's try one more. Again, our a, our b, and our c. So we have negative 3 squared minus 4 times our a is again 1, and our c is 1. Negative 3 squared, negative 3 times negative 3 is 9, and negative 4 times 1 is a negative 4. 9 minus 4 gives me a positive 5. So again, if that number is positive, we know that we have real number factors. So let's put that to some use here. Let's try one more thing. Okay, what values of c would give us two complex roots? So let's go one step further. We know everything about this problem except for what our constant on the end might be. And they want to know what numbers can we have here to get a complex answer. Well, what do we know? Okay, how do we know that we're going to end up with a complex answer? Well, we just talked about if we were to use the quadratic formula. I'll write it down again here. Those last examples we just did, we found out that if this value here is negative, we know we have complex answers. Okay, so let's transfer that over. When will we have complex answers? We'll have complex answers when b squared minus 4ac is less than 0, right? Because less than 0 would be negative. So if this value is less than 0, we know we will have complex answers. We don't know what C is, and that's going to be okay, because we do know that A is 1, and we know that B is 6. We just don't know what C is. C is C for right now. So let's put those values in. So B squared, so B was 6, minus 4 times our A was 1 again, and our C is just C. Okay. Fortunately, we know how to solve equations. Let's start by simplifying, or I guess this is an inequality actually. So 6 squared, 6 times 6 is 36. Here 4 times 1 is 4, times C is just 4C. So we have a negative 4C, and we know that's less than 0. Well, if we solve this inequality for C, we will know which values of C will give us complex roots. So let's try that. I subtract 36 from both sides of the inequality. I get negative 4C is less than negative 36. And finally, I'm going to divide both sides by negative 4 to solve for C. Now recall, with inequalities, anytime you multiply or divide by a negative number, you have to switch the direction of the sign. So negative 36 divided by negative 4 is 9. So we know that anytime C, in this case with these other values, if C is greater than 9, I will have complex roots. If C is less than 9, that will not be the case. Okay, so that is what we can tell using the values in any quadratic function. We can use that quadratic formula, helps us predict what might happen.